Guys, we have a question right here. It's asking find the y prime. So let's see how we can find it. So first of all we have to mention that we have to differentiate with respect to x. Then what I had to do is I had to find the derivative in the both sides. So first of all, if you see here we have two different variables are multiplying each other. Therefore I have to use product rule. So it's going to be y prime, then it's going to be sine x square plus y times sine x square prime. Then in the after the equation it's same thing right here. Two different things are multiplying each other, therefore I have to use product rule. So it's going to be x prime sine y square plus x times sine y square prime. Then what I have to do is y prime is going to be remaining the same, so it's going to be y prime sine x square, and here we have y times sine x square. So we know the derivative of sine x is equal to cos x. So we can substitute here. It's going to be cos x square, and this is going to be a chain rule because we are taking the derivative outside once, then we have to find the derivative of inside also. So it's going to be x square prime. Then here we have x prime is going to be 1 because 1 times x, 1 minus 1 is going to be x to the power 0, so 1 times 1 is going to be 1. So that's it. And then here we have sine y square, it's going to be remain the same, sine y square, and then x times sine y square prime is same concept. Sine derivative of sine is cos x, cos y, so it's going to be cos y square, and it's going to be chain rule because outside derivative and inside derivative. It's going to be y square prime. Then if I solve for this one, I will get, let's simplify more, y prime sine x square plus y cos x square, and derivative of x square is going to be 2x, then sine y square plus x cos y square, and derivative of y square is going to be 2y y prime. So whenever we find the derivative of y, if it's simply y, then it's okay, it's just going to be y prime. But if we combine with, most of the time we use um, chain rule. So in this case, 2y outside, then y prime again. So it is going to be 2y y prime. Now what I can do is I can bring all the y prime to the one side because our purpose is to find y prime. So it's better to keep everything, it's good to bring everything one side, right? So let's bring all the y prime one side. So here we have y prime sine x square. Here we have x cos y square 2y y prime. I bring it to this side. So it's going to be minus, and I multiply this one by 2, this x by this one. So it's going to be 2xy y prime. 2xy y prime cos y square equal to, I bring this one to the other side. This is going to be sine y square minus, I can multiply this one in the front, it's going to be 2xy cos x square. Now I can take the y prime common. If I take the y prime common, I will get y prime common sine x square minus 2xy cos y square equal to, um, now I can, this one gonna remain the same, we don't have to do anything. Sine y square minus 2xy cos x square. Now to find the y prime, I can bring this one to the other side, so y prime will be alone here. So y prime is equal to sine y square minus 2xy cos x square over sine x square minus 2xy cos y square. So this is the final answer. You can leave it as it is, as like this, or if you want to bring this one to the front, you can rearrange it also. If you multiply both top and bottom by negative, it would become 2xy cos x square minus sine y square over 2xy cos y square minus sine x square. So both of them are correct way to write. So because this is the answer we are getting, right? So that's why I want to show you you can write it in the both ways. So this is how we solve this question. I hope you guys understood this concept. See you next time.